All right, now we're in business, yeah? Are we recording? There's a red dot, that's a good sign. We are recording. If you ever watch any of my YouTube videos, it's the highest production value you've ever seen. Let's just say that. My drawings are awesome. My commentary is just really straightforward and very to the point. Not at all. Okay. So physical properties. Anyone have any ideas as to what a physical property would be? You can try and define it, or you can, oh my gosh, there's a T there, properties? That looks right. Probably not, but it looks. So physical properties. You could give me an example, you could give me a definition. Any ideas? I don't know if I'm going to be able to get any of you to talk today. Wilkes? Color? Yes. That is an excellent point. Yes, color can be a physical property. So as an example of a physical property, we can put color. What else? Color is connected to chemistry too, though, so we can talk about that in a bit. Any other ideas of what a physical property would be? Yeah. Anything that you can see. Kind of. Anything that you can see. Yeah. So maybe a little bit more specific for me. How about something that we've talked a lot about lately? Starts with a D. Wilkes? Density. Density is a physical property. Okay? It's how much stuff there is in a place, right? Mass, volume, shape, size. Okay? It is the things that are, I mean, for lack of a better term, physical, tangible, things that are like kind of like you said, Ash, that you can see, that you can touch, that you can, yeah, that you can measure like that. Okay. But we also have things like, I'm gonna just like this, make another text box. Other than these, we also have things, oh, that's really big, like that. The melting point of something. Is a physical property. The boiling point. Remember when we talked about phase changes, right? The phases of matter, the states of matter. How hard something is, the hardness. And yes, there is actually a unit for that. Forget what the name of the unit is, but geologists use it all the time. They scratch rocks with different materials, and you can get a unit for hardness. There's another one called luster. Anyone have any idea what luster is? Ryan? Yes, shiny or reflective. Yep. So again, all of this stuff is the physical properties. Here's another one that is kind of unusual, but is actually super important. The taste of something. The taste of something. And if you think that's weird, geochemists just lick rocks like all the time. Okay, they just do it. All right. I had a geology professor at Utah State. He was a weird dude. I mean, he was a geology professor, so you know he was weird. His name was, he went by Dr. Tom, and he was like 6'4". So for those of you that use the correct measurement system, that's just about 2 meters tall. And he was so lerpy, and just like, and he would, the way that he would walk, he was walking like a deer, like, and he would walk to school, walk to the university every day. He lived like 2 miles away. So you would just see him walking, and he's got his briefcase, and he was probably 70 years old, and just, yeah, he was a funny guy. He also went to like every single athletic event there was. He would go to tennis matches, he'd go to the track meets, he'd go to the men's and women's basketball, the volleyball, he would do it all. Kind of weird dude, Dr. Tom. But he would lick rocks all the time. And he would, like, that was one of the ways that he could determine what a rock was. He would look at it and feel it, and then he'd lick it.
What happened to
don't eat the science? Yeah, whatever happened to that? Yeah, generally, in this class especially, don't eat the science. Okay? We're not going to be doing too many like hands-on labs just because, you know, the Rona, but when we do those, yeah, don't eat the science. But that is a physical property of materials, is the taste. Okay? Questions on that? Maybe? Okay. So all of these, really, the physical properties of something are related to physical properties do not change the identity of the material. Okay? Physical properties are not related to the change of the identity of the material. Okay? If you change one of the physical properties of something, it's not going to change the material, like the actual material itself. Okay? So if I change, so for instance, like if I break something, okay, have I changed the actual material itself? Have I made it into something different? No. If I melt something, have I changed the identity of the material? No. What the identity is the physical, or it's not the physical, is the how the material is at the molecular or atomic level. Okay? So, and this leads us to what is a physical change. And I know you've written physical a lot. I promise that this is the last time we're going to do that. A physical change is when you alter one of the physical properties, okay? So a physical change would be something like breaking, or cutting. No, not budding, cutting. Man, he wrote but on it. That's funny. Cutting, crushing, and you know those, pulverizing, that kind of stuff, that kind of thing, right? Or you can do melting, freezing. Geez Louise, I cannot type today. Well, I can't really type any day. Or dissolving. Okay. These are often, physical changes are often reversible. I'm not saying that it's easy to reverse them, but you can. So for instance, if I break a pot, okay, I can put that pot back together, right? I can generally put that pot back together. Not always. You can generally reverse physical changes. So if I boil some water away, I can condense that water back into liquid water, right? Or if I freeze some water into solid water, we can melt it back to liquid. Okay? So that is a physical property and physical change. Now, when we talk about chemical properties, it gets a little bit more complicated. When we talk about chemical properties, it gets a little bit more complicated. So, anyone have a guess as to what a chemical property would be? Yes.
I almost want to say
Flammability. I would absolutely say that chemical properties would include flammability. Flammability? There's two M's, huh? I don't know about this. I mean, it looks right, and it's not giving me any red lines. So that's a good sign. Okay, so when we talk about a chemical property, flammability, that's a fantastic example. Any other ideas as to what another example could be? Or the lack of flammability, right?
Like the chemical that's kind of makes water fall.
Hydrophobic. Yeah, that could be considered a chemical property. Sometimes it's actually a physical property. It depends on whether it's because of the way the chemical is or the material is like atomic wise or how it is shaped. If it's shaped a certain way that makes water run off of it, then that's a physical property. So we're going to kind of stay away from that a little bit. What else? Any Wilkes again?
radioactivity.
Radioactivity. Absolutely. Radioactivity. Activity? There we go. Swear. Radioactivity, toxicity. Okay. Toxicity, acidity, acidity. Okay. And there's other things that we could use as examples. So for instance, chemical stability. So, or the chemical stability slash reactivity. I think that's right. Okay. Meaning how much it wants to react with other chemicals or not. That is just kind of a general term for like flammability. Okay. There's another fancy term that we could use for like called enthalpy. Swear, I know how to spell scientific terms correctly, but I don't know how to spell like normal words. You know? Ask me to spell, I don't know, geochemistry, and I'll get it right every time. But you ask me to spell like, I don't know, careful, and I'm probably going to screw it up. I don't know why. Okay. So enthalpy has to do with the amount of energy that is released or absorbed in a reaction. But we'll talk about that more later. So these are the examples of chemical properties. Should we go back through and add pictures? Fire. Yeah, yeah. What's the most sciencey looking fire here? How about the one? Ooh, that one looks cool. Yay, fire. There we go. Okay. All right, this is why you come to this class. Okay. Yeah, so now we need to just quickly discuss chemical changes. Chemical changes. So based on what you understand about physical properties, chemical properties, and physical changes, what would a chemical change be? Any ideas? No ideas? So anything that changes the identity of the thing, okay? So changes that affect, let's see here, is this the effect or the affect? Okay. Does that seem right? I don't know. Is it an A? Gosh dang it. Ugh. Are you glad that I'm not your language arts teacher? None of this is important anyway. The identity. Don't tell Mr. Lemon or like Mr. Frower or Miss Davis this, but like when they're asking you to like interpret poems and stuff, it's like none of this means anything anyway. Like, give me something that is measurable. Give me some evidence. Give me some science. That's what you should say, because you want science in your life, right? Okay. Changes that affect the identity of the material. And we can put in parentheses the molecular, or atomic properties. No, not properties. How about molecular or atomic identity properties? Come on, give me a synonym. Gosh dang it. What?
Quality?
Ooh, there you go. Or characteristics. That was the word I was looking for. Qualities. Gosh dang. Qualities. Yeah, all right. Okay. Let's add another picture just so we can have fun. Chemistry. These are always so fantastic. It's always just like a whole bunch of beakers full of liquids of different colors. Nothing says science quite like a beaker full of a strangely colored liquid. See, look at this. It's just like, that's all it is. Most of them are drawn. Come on, give me something cool. Something like, you know, informative. No, nothing. It's all garbage, man. These are all garbage. Whatever, we'll do that one. Okay. We might have to rotate it. Yeah, now we're talking. Okay. And now these nitrogens have become something that starts with a Z. So there you go. Okay. Questions about chemical properties versus physical properties, physical change versus chemical change. These changes are generally not reversible. Usually. Oop. So if I burn something, let's say that I just have a log at my house and I light it on fire and it burns, can I take those ashes and make it back into a log? No, I cannot. That change is permanent. Okay, so physical change versus chemical change. When you see a chemical change, oftentimes there will be like fizzing or foaming. Sometimes there's fire. Sometimes there's a bunch of heat released, or sometimes there's a bunch of heat absorbed. Sometimes there is a color change or an odor change, or there's an odor released. Okay, so these chemical changes, remember how taste was a physical property? Well, if you can affect taste by a physical change, you can also affect it by a chemical change. Okay, so not always is color only a physical property. Sometimes it's a chemical property too. It just depends there. So we'll try and steer away from anything that's confusing that way, where it's both a physical and a chemical property. So for instance, like the color of my shirt here is generally a chemical property, but it can be a physical property as well, depending on how the light is reflected off of my shirt. Okay, so okay, questions about any of that? Chemical property versus physical property versus changes of both kinds. No? Cool. All right, I know that was a very boring lecture, but hopefully you got some stuff out of it, and that's the end of that.